Okay, now we're looking at the voltage directly with our meter and comparing that voltage reading on the inverter display. Okay, 12.5, 12.5, and the meter is measuring exactly across the input of the inverter, which is the plus post and the ground post. Okay, you can see it right there. So that's, let me see, that's the, how do we do this? Okay, the negative is where my ground lead is, on the negative of the cable going into the inverter, and the positive lead is on the positive cable going into the inverter. So what we're reading should be exactly what is displayed on this guy here. So with no load, 12.5, 12.5, right? Okay, so let's find out. Here goes. We're turning on 1200 watts, 11.26 volts, 10.5 volts. So 10.9, 11.2, 10.9. Okay? So we got 11.2. The inverter shows 10.8, 10.5. 11.2, 10.5. And then we'll turn on, so that's the bus hardwire, and we'll see 1300, about 125 amps. So that's the battery status. And this is the actual voltage going to the back of the inverter directly across the ground input, the negative, and the positive into the inverter post in the back of the inverter. And it's not consistent with this voltage. So 10.5 here and 11.2 there. That's why this inverter is turning off sooner than it should. Let me turn on the heater and add 200 more. And you can see 1600 watts, 10.96. But the inverter is showing 10.5 or lower, 10.3. Whereas my battery coming in to the back of the inverter is 10.95. So we got a misreading here. Okay, so turn it off. Turn off the 200. So we still got 10.6 and 11.1 there. Turn this off. Boom. So we're back to no load. 12.3 volt DC. 12.3. So there's a lot of power loss inside the inverter. Enough to cause this thing here to turn off before the battery is truly low. Okay, so not a good thing.